SNC Vista underground distribution switchgear operates at high voltage. Failure to observe the precautions below will result in serious personal injury or death. Some of these precautions may differ from company operating procedures and rules. Where a discrepancy exists, users should follow their company's operating procedures and rules. This video is intended to be used in conjunction with written instructions 681-530 and 695-535. Vista and Vista SD underground distribution switchgear furnished with fault interrupter ways includes a unique microprocessor-based overcurrent control that detects faults and initiates operation of the resettable fault interrupters. The software is easy to use and allows you to program the control using your personal computer via an easily connected USB port. In this video, we'll show you how to connect a PC to the control, give an overview of the software, and everything you need to do on the control before energizing the switchgear. Before heading out to the switchgear, let's make sure the PC is ready to go. We'll need Microsoft Windows and administrative privileges. First, we need to download and install a Vista Overcurrent Control USB driver. Navigate to snc.com/VistaOCC. There are two versions of the driver, one for Windows 10 and one for earlier versions of Windows. We'll use a Windows 10 version, but the other will install the same way. Let's move the file from the Downloads folder to the desktop. We need to unzip the folder inside. We can right-click and choose Unzip. You may get asked for passwords here. I'm logged in as an administrator. Now this setup.bat file needs to be run from a command prompt in order to install the driver. So we'll open a command prompt by using the Start menu. We'll search for cmd.exe. Right-click and choose Run as Administrator. Now we need to change the directory to the folder that has the setup file inside. We can do that by typing cd/ and typing the path to the folder. We can also copy and paste this information from the file browser. Let's simply copy the path up to user in my case. Your path might be different, but the important thing is to leave off the C prompt. Control C to copy, then go back to command prompt, type cd/ and paste. We've navigated to the folder. Then we can type setup.bat and follow the prompts. The driver is now installed and this PC is ready to connect to the overcurrent control. The overcurrent control is housed in an enclosure mounted on the operation side of the switchgear. For undercover style and vault-mounted style Vista and Vista SD switchgear, the enclosure is fully submersible and the control should not be removed for bench programming. For pad-mounted and dry vault style Vistas, the overcurrent control's electronics module is removable for bench programming. The written instructions give a lot more information on removing the control from the enclosure. Here's the USB port on the control. Just take the cap off and plug in a common USB-A type cable. The other end plugs into a PC. After connecting, we can access the control by opening a web browser. Let's open Microsoft Internet Explorer 11. There's a quirk with Internet Explorer 11 and older. We don't need to do this with other browsers. Click on this gear icon and navigate to Compatibility View Settings. We need to uncheck this Display Internet Sites in Compatibility View checkbox. Then click Close. If we don't do that, the programming software may not run properly. At this point, we can navigate to SNC Vista. This will bring us to the login screen. There are three types of logins: Admin, User, and View. The logins Admin and User have default passwords which we'll find in the written instructions. To log in as either, enter the appropriate username and password fields, and then click the Login button. SNC strongly recommends changing the admin login password from the default setting when first logging into the control. We will be prompted to change the user login password the first time we log in under this username. To use the control as a viewer, simply click the View button. Let's look at the differences between each login. The admin login allows the user to have full access to the overcurrent control, allowing programming of the protective settings and the control settings, as well as permission to change both the user and admin passwords. The admin can perform trip tests and upgrade the control's firmware. The user login allows the user to program the protective settings and view the status of the control, firmware revision, and event logs. The user login cannot perform trip tests, edit the control settings, or update the control's firmware. The View mode should be the typical means of accessing the control. It allows the user to view the status of the control, load currents, protective settings, firmware revision, and event logs. The View mode can also be used to clear event logs. No changes to the protective settings or control settings can be made. For our purposes, we will log in as admin, as if it's the first time we're using the software. After logging in, you'll see this menu down the left side and information for that menu in the middle. The first thing we'll do is reset the admin password. Navigate to the control settings, and from there just follow the standard form to create a new password. The password must be between 4 and 12 characters with at least one letter, one number, and one of these special characters. Keep in mind, too, that both the username and password are case-sensitive. It's very important that you do not lose the password. For security reasons, there is no password retrieval system built into the overcurrent control. If the admin password is lost, the control must be returned to S&C Electric Company to restore access to the control. Let's continue the tour of the software. We start on the status screen. This screen provides a summary of the status of the overcurrent control settings. This is the overcurrent control status display. It replicates the user interface on the control. There's a handy little key displayed right next to it to tell what the different colors mean. If the switchgear experienced a trip event, the corresponding fault interrupter LED would be solid orange. The overcurrent condition A, B, and C LEDs show the phase involved with a trip event, so we would see one or more of those lit as well. The Q indicator represents a negative sequence setting, and the G indicator represents a ground setting. If either of these elements initiated a trip operation, the light would be red. The Control-enabled LED will blink when the control is working normally, as it is now. If the Control-enabled LED is solid green, the control has an error and may not perform properly. Contact S&C for support. See the written instructions for a more complete explanation of the different statuses. To clear the overcurrent condition indicators after an overcurrent event, click and hold the Reset button until all LEDs show a solid color. The Load Current menu shows a snapshot of the load current going through the two interrupting ways or through ground. It can be refreshed by clicking the Reset button. Below the load current, we can view control settings. These settings cannot be edited from here. If we were logged in as viewer, this is where we would go to check the settings. We'll show you how to program these settings later in the video. And at the bottom we find the About section, which lists the login we're using, the controller name, MAC address, the bootloader and firmware version. That's the status screen. Below the Status tab, we have controls for each interrupter. The interrupter IDs are programmed at the factory to match the way designation of the switchgear. So here we have Way 3 and Way 4. We can rename these however we want as well. If you are in admin or user mode, you can program the protective settings from here. You can see all the different fields you can set. There's a lot of information in the written instructions on all of these attributes. You should be very familiar with that document before you try and program the device. All ways are set at 200E as factory default protective settings. I'll show you some basics of programming in a bit, but first let's move on to the Control Settings tab. Again, you can change the user and admin passwords from here. Below that, you can change the name of the interrupters. they will display with the new names on the left menu bar, the status screen, and event logs. The Global Settings menu is next. Here you'll find the switchgear frequency, the continuous current ratings, the fault interrupting ratings, and the trip mode section for both ways. SNC will have programmed these settings at the factory. It's important to check that all of these settings match the nameplate on the switchgear. The trip mode setting can be changed here. See the written instructions for the different trip modes. If the switchgear is being used on a 50 Hz system, you can change that here. The USB network settings is where we can find the MAC address, IP address, subnet mask, and default gateway information. And finally, here is where we can reset the control settings to their factory defaults. Simply click the checkbox and then click the Reset to Factory Defaults button. Notice, SNC programs the global settings at the factory. The factory default reset setting will restore the settings back to the overcurrent control's pre-programmed state. You must reprogram the global settings for the overcurrent control after performing a factory reset to match the configuration of the Vista switchgear that the control is monitoring and controlling. Passwords are also reset after factory default settings are restored. When we click on the Event Logs tab here below Control Settings, we'll see the last 64 events recorded by the trip event log. The trip event log will record event messages in the order the event occurs, with the most recent event on top. Trip events will remain recorded even if the control loses power and will only be removed if more than 64 events are recorded. The oldest event will be overwritten, or if the log is cleared manually. The Event Cause column will show the cause of the event that occurred, and the Event Type column will display which element initiated the event. The interrupter that responded to the event will be displayed under Faulted Interrupter, and the time overcurrent phase or element will show up in the Fault Status column. The phase current at the time of the event is also shown. We can clear the event log by clicking here. The Diagnostic Event Log shows the last 12 diagnostic events recorded by the overcurrent control. This is used mainly by SNC Electric Company to help troubleshoot any problems with the overcurrent control. You should report any error messages to SNC through the Global Support and Monitoring Center. Below that, we find the Control Self-Test Report. The overcurrent control tests vital subsystems upon power-up and periodically during operation to ensure the control is working properly. This status field will show any errors or display OK after a test. Any errors should be reported to SNC. This is also used mainly by SNC in troubleshooting. Trip tests can only be performed under the admin login. Note that test tripping the overcurrent control will open the fault interrupter and may cause unplanned loss of load. See the written instructions before performing a test. Finally, we have the last tab, Firmware Update. If directed by SNC to update the firmware, here is where you would upload the new firmware file. Now that we've been through a general overview, let's take a look at how programming the fault interrupters works. Let's click on the Way 3. There is a lot more detail on all the attributes in the written instructions, so I'm not going to go through everything, but let's look at a few different programming scenarios. Way 3 is configured for 3-pole trip, 3-pole lockout. The overcurrent control has 4 TCC or curve families: IEC, IEEE, Vista Coordination, and Vista Speed. We select which family we want to use here with the drop-down. Let's start by looking at the 2 Vista families. Vista Speed emulates common fuse curves like E, K, and T. Vista Coordination includes proprietary Vista Tap and Main curves. This is for a 3-phase fault interrupter. Note that all phases are programmed under Phase B. Phases A and C are grayed out and are not editable. We're currently on Vista Coordination, and we can see which attributes are editable. They will be white, like inverse segment. The attributes that we cannot edit are gray, like time multiplier. If we select a different family, it will make the appropriate attributes editable. If we use the IEEE or IEC curves, the minimum trip current, time multiplier, and time adder are available to edit. Available ranges and set points are shown in the written instructions. If we want to add a low current cutoff, we first have to enable the setting, and then we can enter a value. This setting is available with all curve families. Definite time phase protection element 1 and 2 also require us to enable the setting and then enter the associated current and time values. They are available with the Vista coordination, IEEE, and IEC curve families. The same is true below, where we find ground protection, negative sequence, and sensitive earth settings. Say we want to add ground protection. We first have to enable ground protection, and all the values change from gray to white, which tells us they can be edited. To save our settings, just click Save at the bottom of the screen. We'll see this green text telling us that the save was successful. That's generally how protective settings are selected. Let's look at a single-phase fault interrupter. Way 4 is set for single-pole tripping and single-pole lockout. Each phase can be programmed with separate protective settings. We can see phases A, B, and C are all enabled. None are grayed out. Settings are chosen the same way as three-phase fault interrupters. If we want to use the same settings for all three phases, we can select the checkbox, Select to save same settings to all phases. It will gray out phases B and C. Then we can make changes in phase A. Once we save, phases B and C update so all three phases have the same settings. However, settings for ground, negative sequence, or sensitive earth settings are not available with this trip mode. They are available under single-phase trip, three-phase lockout, which is changed in the global settings. For a fault interrupter configured for single-phase tripping, three-phase lockout, settings will be selected in the same manner as for three-phase fault interrupters, except settings are selected under phase A. Now let's say there's an invalid setting. We can use a low current cutoff as an example. When we try and save, we'll get this message in red. Notice that it hasn't actually saved. The control will not save invalid settings. The message tells us what needs to be fixed and highlights the field in yellow so we can come back down and make changes. Also, if we leave the form without saving, we'll get this pop-up message. For information on additional settings, please refer to the written instructions. That's a general overview of the software. If you have any questions, please see the written instruction sheet 681-530 for Vista or 695-535 for Vista SD. If you need to open a support case, you can do that at the S&C Customer Portal or by calling our 24/7 Global Support and Monitoring Center.